all right. 3.1, let's have some fun. 3.3, sorry. 3.3, don't listen to me, here we go. All right, we got these two problems here, okay, number one and number two. I'd like you to try those on your own. I'd like you to pause it here, okay? Give those a shot. Consider them a warm-up. I want you to solve for x. You set up a proportion to solve for x. You might have to factor a little bit with this one, all right, and give it a shot. And then tell me if these two are similar, and if they are similar, tell me why. Give me the reasoning. Is it side, angle, side, or angle, angle? Go for it. All right, so with this one, your setup should have been x over 4 equals 6. So something like this, you could have done x over 6 over x plus 2. Either way, you needed to cross multiply like this and get x times x plus 2 equals 24. And you had to distribute the x. Plus 2x equals 24. And guess what? Like I said, you're going to have to factor. You need two numbers that multiply to negative 24 and add to 2. Those two numbers are 6 and 4. X plus 6, x minus 4 equals 0. So x equals negative 6 and x equals 4. Well, since it's just x here, I can toss out the negative 6, and x is just 4. All right, a lot of today is going to be solving proportions, okay, so it's important that we have that practice. All right, for this next one, number 2. Are these triangles similar? Okay, are these triangles similar? Well, I know that this is 135 and this is 20. All right, so I have to find out the measure of this angle. Okay, well, 135 plus 20 is 155. 180 minus 155 is 25 degrees, which means this angle has to be 20. So it would be a yes by angle similarity. All right, so in this actual section itself, we're going to be looking at a lot of similar triangles, okay? And I'm not going to sit here and be like, oh, they're these similar every single time, but I'm going to stress on the first one, and so that we know that it applies for the rest, okay? So let's talk about today. Today we're identifying the relationships between parts of a right triangle when an altitude is drawn onto to the hypotenuse. Remember, altitude is a segment that creates a right angle that is perpendicular to its opposite side, starting at the vertex. So here in this picture, CD would be considered our altitude, all right, because it starts at a vertex and is drawn to the opposite side and is perpendicular to that side, all right? So in today's lesson, we're going to try to identify, I want you to try and think about this here. Before we move on, I want you to think about, in this picture, in this diagram, how many triangles do you see? How many triangles do you see? Take a second, think about that. How many triangles are here? Do you see one triangle? Do you see two triangles? Do you see three? Do you see four? Do you see five, et cetera, et cetera, et cetera? All right, so I want you to think about that, start to get those wheels turning a little bit. How many triangles do you see? Well, when an altitude is drawn onto a hypotenuse, like CD of ABC, 3 similar triangles are formed. You have the big one, the big triangle. Let's see, since I don't have a purple, I'm going to use green. So I have the big triangle. All right, sometimes people forget about the big triangle. A, C, D. I call that the large triangle. So I have the blue triangle here. Okay, that is CDB. I call that the medium triangle. And lastly, I have this smaller one, ACD, and this is the small triangle. So we're going to be, our goal of today is trying to identify, okay, are we looking at the small, the medium, or the large triangle? Okay, that's what I want to identify here. All right, are we comparing those two similar triangles? Which two similar triangles are we comparing? That's what we're trying to figure out within each problem. Okay, that's going to help me set up. That's going to help me set up my correct proportion. That's what I want to decide. Which two triangles am I comparing? The small the medium, or the large? Well, in Starbucks terms, since I'm drinking Starbucks right now, is the tall, the grande, or the venti? This one's a venti, okay? But let's see. So looking at this problem here, okay? Looking at this exact problem, all right? I want to decide, like I said, the small, the medium, the large. What I want to ask myself when I'm comparing these two triangles, which one has two side lengths, okay? And what I mean by that is I want to include x, all right? If I look at the small, the medium, or the large, are there two side lengths marked, okay? So if I look at the small triangle, my small triangle is here. You'll see that I have the 3 and x. So I want to redraw that triangle. All right, I want to redraw it separately, take it out of the picture, 3 and x. All right, so the small triangle is one of them. Check. Medium triangle. Outline my medium triangle. Now you could be doing this with a different color pen. You can be doing this with your finger, whatever it may be. All right, I outline the medium triangle. Looks like I have an x and 9. So that's two sides. So I have x and 9. So that checks out. So that tells me right away that I'm comparing my small medium. I'm not even considering the large. All right, if you look at this large triangle here, the only side you have is this one. That's only one side. X is not a part of the large triangle. It's not AC, it's not CB. So I don't want to consider the large triangle. I want to ignore it. Unfortunately, so sad for the large triangle. All right, no thank you. No thank you. So the next thing I want to ask myself, okay, when comparing these two similar triangles, all right, my small triangle and my medium, what appears twice? What appears twice? 3 doesn't appear twice. X appears twice. So since X appears twice, I'm going to set up my proportion like that. Whatever appears twice needs to be across from each other. Needs to be across. Or you could have set it up like x over 3 equals 9 over x, recognizing that, hey, x is still across from each other. Okay, the x's are still across from each other. That's the biggest thing. That's how we're going to set up all these problems. Whatever appears twice goes across. Okay, it could be a number too. I could have like 10 appearing twice, and then I put 10 here and 10 there. Okay, it doesn't always have to be x. It doesn't always have to be x. And then from there, we just cross multiply and solve. X squared equals 27. How do I get rid of a squared term? I square root both sides. 27, I can simplify as I want to find a perfect square that multiplies into 27. It's 9. Square root of 9 times the square root of 3. Well, that's 3, radical 3. I'm done. 3 radical 3. All right, let's try another one. Okay, notice my x is in a different spot here. All right, so again, same question I need to ask myself. Small, medium, or large? Okay, so I look at the small triangle here. Oh, I got two side lengths there. I have x and 3. So that one checks out. Yes, please. Look at the medium. The medium only has the 9. So that's out. Adios. So lastly, I look at the large. Holy buckets, I have x. So I'm going to draw the large. X. And I have 12. Entire side. I want to add those two lengths together. All right, so now in this problem, in example number 2, I'm comparing my small and my large triangle. Well, again, question we have to ask ourselves, what appears twice? Again, x appears twice, so I go 3 over x equals x over 12. The hardest part about these problems is recognizing which two triangles am I going to be comparing. All right, which two triangles do I need to use? From there, it's just solving a proportion and using cross multiplication. X times x gives me x squared. 3 times 12 gives me 36. Square root both sides. Well, what's the square root of 6? Square root of 36 is 6. Now, I should have asked this on the last question. Do I include the plus or minus here? Okay. Since x represents a side length right here, x is CA. Since x represents a side length, I don't include plus or minus. All right. I just want the positive answer. I cannot have a negative side length, so x is just 6. All right. Wow, this is getting fun, isn't it? I can tell. Look at your face. It's fun. Let's try another one since we're having so much fun. All right, last one, and then we're going to come back together and do number 4 as a class. Okay. Example number 3. Again, same question I need to ask myself. Small, medium, large. Look at the small triangle. I only have the 21. So the small is out. Bye, small. I actually have a friend whose last name is Small. Made me think of him there. Bye, Small. Adios. Adios, dude. So funny. All right. So I look at the medium triangle here. Oh, look, I have x and 10. I want to use that. X and 10. And I look at the large triangle as well. Oh, look, I have 10 and this whole side here. So how do we write that? How do we write that as an expression? How do we, write AB? Okay, what do we use for our expression for AB using 21 and x? All right, so I'm going to refer, now you may think of it, I got this. I know what it is. I'm going to refer back to the last diagram here. Remember, when I wanted to use AB, I called it 12. How did I get 12? I did 3 plus 9. Same idea. Thank you so much. Same idea here. I want to add these two lengths. So I'm going to write this as 21 plus x. Okay, not 21x. That's different. That'd be multiplying. 21 plus x. All right, once I do that, okay, I want to compare my two triangles. What appears twice? Now I know what you're thinking. Well, look at Mr. McCordy. X actually appears twice. However, x is not isolated. Okay, there's a difference between 21 plus x, that's an expression, and just x. What appears twice is actually this 10. This 10 appears twice. Okay? Because x is being added to 21 here, these are not the same thing. These are not the same thing. We should know that. That's like saying 2 and 2 plus 4 are the same thing. It's not, right? It's obviously not, okay? But 10 and 10 are the exact same thing. So I can set it up as x over 10 equals 10 over 21 plus x. Now you should maybe recognize why I asked you to factor in the first problem, because we're going to have to factor here. So what I want you to do, I want you to pause this video, cross multiply, and give it a shot on your own. All right, so this is what I've gotten so far. Okay, so you can check your work so far. I got x times 21 plus x, which gave me 21x plus x squared equals 100. Moving that 100 over, writing this in standard form, x squared plus 21x minus 100 equals 0. Now I want two numbers that multiply to 100 and add to 21. Thinking about quarters compared to $1. How many quarters make $1? Oh, 4. It should be 25 and 4. All right, so x equals negative 25 and x equals 4. Same thing as our warm-up. I can toss out the negative 25 here, and x is just 4 because I can't have a negative side length there. All right, that's the end of the video. We'll see you back in class shortly.